Hi, my name is Kirby Hong. I'm a product marketing manager at Anritsu Company. Today I'm here to show you how the ultra-portable MS2760A spectrum analyzer can make measurements on a mmWave FMCW automotive radar. In this setup here, I have the MS2760A directly connected to a horn antenna that is looking into a radar evaluation module from TI. The module is configured by software running on this tablet here. It is configured to send out a 1 gigahertz chirp from 76 gigahertz to 77 gigahertz. The chirps are organized into frames, each frame having 16 chirps. The frames repeat at a 20 frame per second rate. The first measurement that I want to show you are time domain measurements in zero span mode. Since the frame rate was 20 frames per second, we expect to see the frames repeat at a 50 millisecond period. So here in zero span, we have a 100 millisecond sweep time, so we expect to see 2 frames. These 2 frames are separated by 50 milliseconds in time. And to see that more clearly, I can turn on some markers. So I set the first marker at the beginning of the first frame. Then the second marker I will place at the beginning of the second frame. Then I'll turn on the delta marker on the second marker, and then turn on the marker table. And here we can see that the time delta is indeed 50 milliseconds. One thing to note about zero span measurements is the triggering. In this measurement, I set the trigger to video trigger at a level of minus 40 dBl. I have set a delay of minus 10 milliseconds so that I can see some pre-trigger events. There's a hold-off time of 20 milliseconds. This is just slightly longer than the duration of all these 16 chirps in the first frame. The reason for that is without the hold-off, the trigger could trigger on each individual chirp instead of the frame. So the display looks unstable. This is much like an oscilloscope. So if I turn on the hold-off, it's a lot more stable. On the next measurement I want to show you will be frequency domain. In the frequency domain, I've set the span to 1.2 gigahertz, which is just slightly greater than the 1 gigahertz chirp bandwidth. Right now we see nothing on the screen. The reason is because the chirps are occurring at a rate much faster than our sweep rate. In order to see the envelope, we have to set a minimum capture time for the sweep. We can do that in the sweep menu. So I go into the sweep menu, and in minimum capture time, I set that equal to 100 milliseconds. 100 milliseconds is equal to twice the frame period. This will ensure that we will capture the envelope of the chirp. As you can see, the envelope is starting to form up very nicely. And there we can see a 1 gigahertz wide FMCW envelope. To summarize, today I've shown you how the ultra-portable MS2760A spectrum analyzer can make time domain and frequency domain measurements on a FMCW automotive radar. For more information, please go to www.anritsu.com.